Okay, welcome back everybody to this video. Today we're going to be looking at a problem that doesn't necessarily involve too complicated of topics. In fact, everything that we're going to use here is covered in Calculus 1. However, it does require some tricks that you might not think of to use on your own. So I thought it would be still a worthwhile problem to discuss. So this specific question is from the January 2019 comprehensive exam, and it is question number 4. And it says, assume f is continuous on the interval 0 to infinity, and for any ab greater than 0, the integral from a to ab of f of x dx is independent of a. So basically, right, what that's saying is no matter what our value of a is, this integral is going to have a fixed value. So it is our goal to show that f of x is equal to c over x for some constant c. So we're going to use a very important theorem, namely the fundamental theorem of calculus, or the FTC. And there are two parts. This is what I like to refer to as the first part of the fundamental theorem of calculus, although, as you probably know, different textbooks mix the two up. So that is going to state that if we have an integral and it's a definite integral from a to b of f of x dx, if we take the integral of this, that's actually going to be f of a, or f of b, sorry, minus f of a. Okay? So that's what we get here. And so if we apply that to this integral, right, what we're going to get is the integral from a to ab. All we're going to do is switch that, right? That's going to be of f of x, of f of x dx. That's going to be equal to f of ab minus f of a, right? And for any value of a, if we fix b as a constant and let a vary, right, this is going to be equal to some constant c. We can call it whatever, let's just call it c, right? So because we know that as a changes and b stays fixed, our value of this expression right here is not going to change. This is an identity in a, right? So what we can actually do is we can replace it with x. And we don't really need to do this step. Ooh, let me actually go back. Yeah, we don't actually need to do this step, but I think it's easier to see what's going on if we think of it in terms of x, right? So minus f of x equals c. And here is the tricky part, right? Because we have some, right, capital antiderivative function, and we only care about the lowercase function, the original function, we actually want to take the derivative of both sides, and that will preserve the equality. So if we take the derivative of both sides with respect to x, what is that going to give us? Well, we see using the chain rule that the left side, sorry, of the equation is just going to become, right, the original function, and the left side, or the right side, sorry, I keep switching them, is just going to be 0, right, because c is some constant. So what we're going to do is we're going to have f of bx, right, and using the chain rule, because we have a fixed constant b, that's actually going to turn into b f of bx minus our original function f of x, right, which is what we care about, that's going to be equal to 0. Or in other words, moving that over, we get, right, b times f of bx is equal to f of x for all values of x. Now, what happens, right, if we divide this whole thing over, right, or this b over at least, and keep the f of bx? Well, that's going to give us, right, f of bx is equal to f of x over b. Now, if we go up to our original, right, problem, this is going to say for any, right, for any a, b greater than 0. So what we can actually do is we can use a trick where now we can fix some value of x, right? And we can say let x equal any number. We know it's true for all x. However, we also know that it's going to be true for all b. So, right, what we're going to do is we're going to let x just be equal to 1, right? Because it's true for any positive number, because we know that its domain is at least 0 to infinity, right? So let's just say, right, f of 1b, or just f of b, that's going to be equal to f of 1, which we don't know what that is, but that's okay, over b. Now, again, because this holds for all positive constants b, we can just replace that with x again, and we get f of x, which is the function we care about, is equal to c over x, where c is just f of 1. And we don't know what that is, but it's some constant, and that's what we're trying to prove. And that concludes what we're trying to do, right? Because we just want to show that f of x is equal to c over x. We're just trying to show, right, this is true, and that is what we have done. So this is actually not too bad of a problem, but it requires some steps that you wouldn't automatically think of to do. And you have to get a little bit creative with your technique here. So just to summarize, right, we use the fundamental theorem of calculus, right? And we say, since this is true for all values of a, and since a actually doesn't really matter, it's independent of a, we can replace it with x and differentiate it. And what we're going to get is b times f of bx minus f of x is equal to 0. Then we rewrite the equation, right? And again, because this is also true for all values of b, we can replace x with just 1 and get this right here. And then we can allow b to vary, so we're going to use x to kind of signify the thing that we're changing or letting vary, and we end up with exactly what we're trying to show. So if you have any questions about this problem, definitely make sure to let me know, and thank you for watching this video.